Hi, this is Ed from Wright. Today we're talking about clutches. The clutch on your mower is a very important component. It's a bit of a complex component. There's a lot going on here, and there's some things you can do to get more life out of it. Today we're talking about how the clutch works, how to troubleshoot a clutch, some of the critical things when installing the clutch, and lastly we're going to talk about some of the things that you can do to get more out of the life of your clutch. So let's first talk about how the clutch works. You have a crankshaft that goes down through the clutch. You usually have a drive pulley like this. This is the pulley that's driving your hydro system. It's very important that it's got a very flat surface here and it's supporting the clutch well, because the clutch is actually held together by the clamp force against the engine. So you want to be sure that everything is flat and sitting good. So then the engine drives a rotor that's inside here. You can see there's a keyed shaft in here and it spins the rotor on the inside. So let's open this up. Spins this rotor right here. And when this rotor spins, then the clutch is not disengaged, it just spins the whole time. When the clutch needs to be engaged and you pull the switch, it actually energizes this big, huge electromagnet. This is like 60, 70 watt electromagnet, pretty powerful, and creates a magnetic flux around here. So these little slots let the magnetic force pull through, and it pulls this plate against the spinning rotor. And as it pulls against that plate, it causes the pulley to begin spinning. Now, you can see that this little plate is flexible. It's on this set of springs in here. They're all spiral shaped, and they're under tension. So there are clockwise and counterclockwise clutches. You never want to install a clutch, the wrong kind of clutch, backwards on your machine. Otherwise, these will be immediately destroyed. So when this thing spins, it drives your deck. When you turn it off, this plate actually retracts, and on the field coil here there's a brake that hooks behind that plate. So when it's disengaged, this clutch here drags against these little magnetic brakes, and that's what slows down the deck. Now when a clutch begins to not work, it's because either that brake or the main plate is beginning to become worn. So this is a Warner clutch, a very common clutch. There's also an Agura clutch. We offer both of them on different machines, depending on the model. This is an Agura clutch. This clutch is actually very similar. You can see here's the top here, the magnets inside here. The biggest difference here is that the rotor is a one-piece solid rotor, so it doesn't come apart into three pieces. It does have an adjustable brake. So instead of having a little brake on one edge, it has a ring all the way around it. It has these three nuts. So you can adjust the gap between the clutch and the rotor. So very similar here. This one has a bolt-on pulley, so you don't see the pulley on this end. But it functions on the same principles. Now let's talk a little bit about troubleshooting the clutch. First off, I've seen clutches replaced when the problem was actually on the side of the machine. You want to be sure that the clutch is getting power first of all. Now, if you go to engage the clutch switch, and you hear a click noise down by the clutch, then you know that the clutch is getting power. If you don't hear anything, you want to confirm that. You want to use a multimeter, set it to voltage setting, and you want to measure the voltage at the wire going to the clutch and make sure it's getting about 12 volts. If it isn't, then you know you have something wrong with the rest of the machine. If it is getting power, then you know your problem's within the clutch, or a problem of power getting to the clutch. So at that point, what you want to do is identify if the electromagnet on the clutch is still performing how it should. And the way you do that is you take your multimeter, you set it to ohms. And each clutch has a different ohm requirement, and generally it's between 1.5 and 2.5 or 3 ohms, somewhere in that range. And you can just connect that to the two poles in here, read the measurement, and make sure that you have the right amount of resistance. If you have a number that's too high, that means that there's some kind of a disconnect in there and it's got a circuit that's more open than it should be. If you get a number that's a lot lower, that means that maybe some of the wires in the winding are shorted out against each other, and so it's drawing too much power, creating too much heat, and not enough of a magnetic field. So you need a multimeter to identify whether it's the coil or not. Once you know that, if the coil meets the spec, then you need to move on to the mechanical side of the clutch. Looking at the mechanical side of the clutch, there's a few things you're looking for there. I have an example clutch that's had a good life. You can see the coil's still in good shape here. It's just dusty. But the rotor and the brake here, you can see the rotor has a lot of grooving in it, so it has a lot of wear. And then the brake here, you can also see that it's pretty well worn out. And so there was a gap that was too big for the magnetic pull of the clutch to engage it. You can also have issues where maybe the springs in the clutch could have cracked, and so this could be falling off, falling loose, making a lot of rattling noises, and that means your springs are broke. Any of these problems mean that you want to replace the entire clutch. You really want to know whether the ohms, you want to make that ohm measurement, because if it fails right away, that's where you stop and put a new clutch. If it's good, then maybe there's something that can be done to salvage that clutch. So those are some of the things that you're looking for when troubleshooting exactly what the cause of the failure is in the clutch. Now, if you did determine that you need to replace the clutch, oftentimes the dealer is best equipped to do that. It can be a little bit tricky, but a few things that you really want to be careful about. When the clutch mounts up against the engine, you want to be sure that the drive pulley is clean and smooth. Also, you want to be sure that it's properly torqued. Most clutches are held in by a 7/16 fine thread bolt, and each different mower out there is going to specify a different torque, but generally it's between about 50 and 60 foot-pounds of torque dry, and that's going to allow the clutch to have enough clamp so that nothing is moving around. If anything moves around under load, the clutch will just destroy itself very quickly. If it's too tight, you can start binding up and squishing some of the parts. So getting the torque correct, using the right bolt, that's important. The other thing that's important is that there's a wire leading the clutch, and there's a field coil in there, and it moves just a little bit throughout its life. There's a lot of vibration. It's really important that this wire is properly fastened. If there's too much of a loop and it vibrates, this can actually fatigue the wire. If it's too tight, it can yank the wire out. So you want to install the wire exactly the way the manufacturer had it. That way you'll get the most out of your wire. So lastly, how do you get your clutch to last longer? Well, first off, the clutch doesn't actually wear out very much while you're running the blades or when the blades are off. The clutch actually wears when you disengage and you engage it. So when you engage the clutch, this main surface right here is your friction area, and that's what's rubbing. When you disengage it, this back edge to the clutch right here and this little edge of the brake here is what wears out. And actually, in this case, this clutch failed because of the brake, not because of the actual clutch surface. Just enough cycles will eventually get to that point. Now, most clutches in heavy-duty commercial application are capable of many, many cycles. And we know that on a stand-on mower, you're going to go through more cycles than on a Z mower because you're more efficiently using your time, you're multitasking on the property. And so when you break that all down, you look at the replacement cost of a clutch and how many cycles it goes through, we're talking about 2.5 to 3 cents per an engagement or a disengagement with the clutch. And the amount of wear that takes place there has a lot to do with the speed of the engine compared to the blades being at their stop point, whether it was stopping or accelerating. And that difference in speed creates the wear. If you can halve the difference in speed, you can almost half the cost of an engagement. So you can go from about 3 cents to about 1.5 cents or maybe 1 cent per engagement if you throttle the engine down half speed or maybe 1/3 speed. Now, some manufacturers recommend that you engage the blades at full throttle, and that's really tough on the clutch. I mean, if you had a car with a manual transmission, are you going to put the engine to full speed and drop the clutch? This is usually not advisable. Your clutch is not going to last very long at all. But sometimes they recommend that you go full speed just so the belt doesn't pop off or there's no surging in the drive. Now, you can slow the engine down as much as you want as long as the belt isn't surging and the engine isn't chugging. If those two conditions are good, then it's okay to engage your clutch when the engine's running slower. And that way your clutch will last a lot longer. So hopefully that helps you understand a little bit how a clutch works, how to make the most of it, how to make your money go as far as you can. Thanks for watching.